SEDEMAC Variable Speed AC/DC Kit Fitment Procedure. In this module, you will see the retrofit procedure for the SEDEMAC Variable Speed Genset Kit. Retrofit Procedure: conversion of fixed speed genset into a variable speed genset using retrofit kit. Before we get into the procedure, let's have a look at some key points. The fuel-saving variable speed genset technology is available from Mahindra & Mahindra for all new gensets, as well as for old existing gensets in the field. For old gensets, this technology is being offered by Mahindra & Mahindra in the form of a retrofit kit, which can easily transform a fixed speed genset into a variable speed genset at the telecom site itself. The entire retrofit process is limited to the genset alone. In other words, you don't need to modify the PRU or PMU, the telecom SMPS or the BTS battery. The complete retrofit process will take only about 4 hours at the site. All you need to do is to carry a retrofit kit on a two-wheeler to the site. The best part is the retrofit can be easily done on any existing telecom site, whether it is 10, 15, 20, 25 or 40 kVA single-phase or three-phase at the telecom site itself. An important point to remember is that the retrofit kit part numbers are different for each rating. So make sure you have the right retrofit kit with you before you visit the telecom site for retrofit. Let's have a look at the components of the variable speed AC/DC kit. Item number 1. New I-18 actuator and FIP linkage for engine start, stop and variable speed operation. Item 2. Mounting bracket for the new I-18 actuator. Item 3. New control panel with inverter inside. Item number 4. Mounting stand for the new control panel. Item 5. New engine wiring harness with connections for all engine sensors and switches. Item number 6. New power cable to connect the DG alternators output to the new control panel. During retrofit, only 3 changes are made to the DG as follows. The new I-18 actuator replaces the FIP's stop solenoid. The new control panel replaces the existing DG control panel. The new engine wiring harness replaces the existing engine wiring harness. Now let's take a look at the retrofit procedure. Preparation for retrofit. Care should be taken that the BTS battery is fully charged and can supply power for at least 4 hours. Ensure that the DG is off. Remove the cable connection from the DG battery. Now, remove the stop solenoid. For this, disconnect the stop solenoid from the FIP's lever and remove the solenoid mounting bracket bolts. Remove the existing engine wiring harness. Remove the power cable from the alternator's output. Remove the existing DG control panel from the DG, but do not disconnect the panel connections at the PIU/PMU side. Remove the stop lever spring from FIP as per following steps. First, remove the stop lever's bolt carefully with the help of spanner. Open the stop lever's bolt and remove the spring cap from FIP. Remove the return spring from the spring cap. Do not remove the O-ring from the FIP. Fix the spring cap, stop lever and bolt with the help of spanner in correct direction. Do not over-tighten the bolt. Check that the FIP stop lever is free to move. Now we will install the new I-18 actuator on the FIP. First, install mounting bracket on engine flywheel housing. Then mount the new I-18 actuator on the mounting bracket. Now, connect the actuator's linkage to FIP's stop lever. The I-18 actuator has been installed. Now we will carry out the installation of the new control panel. First, mark holes for the new control panel mounting stand on base frame. Drill holes on the base frame. Then install the new control panel on the new control panel mounting stand. The new control panel has been fixed. Now we shall carry out the installation of the new engine wiring harness and power cable. Connect the new engine wiring harness to starter motor, all engine sensors and switches. Connect the 16-pin connector and 4-pin connector of the new engine wiring harness to the new control panel's 16-pin connector and 4-pin connector. Fix the wiring harness properly on the engine. Connect the 18-pin connector of the new engine wiring harness to the new I-18 actuator. Connect the new power cable between the alternator output and new control panel using proper gland provision. Ensure that the line and neutral are connected properly. Now we will begin the process of integration of the new control panel with the PIU and PMU. First, very carefully remove the PIU-PMU cables for remote start, stop, LLOP, HWT from the old DG control panel. Remember the function of each of the PIU-PMU cables. Connect them properly. Now connect the PIU cables at label points in the new control panel. Connect the remote start, stop, LLOP and HWT Note that if the old DG panel contained a PIU relay card for remote start-stop purpose, then use the same relay card between the new control panel and the PIU start-stop cables. Let's have a look at the crucial step of connecting the inverter output to the PIU PMU. There is a 230 volt 50 Hz inverter in the new control panel. In the new advanced variable speed AC DG kit, the DG output power is available at variable frequency and voltage. This can generate under voltage and under frequency alarms in the PIU. To avoid the PIU alarms, connect the inverter's output signal to the voltage and frequency sensing card inside the PIU. Connect line and neutral properly. An important note: if the PIU contains a filter capacitor between sensing terminals of its control card, make sure that you remove the filter capacitor. This filter capacitor can damage the inverter, so do not forget to remove it. To carry the inverter output towards the PIU, you can use free cables between the genset and the PIU PMU if available on site, or otherwise you may connect new cables for this purpose. We will now begin the final checklist and commissioning process with the new variable speed AC-DG kit fitted on your genset. Connect the battery cable of the DG's 12 volt battery. Disconnect the new I-18 actuator from the new engine harness. Now, hold FIP's stop lever manually to full speed position. Start the engine. Check the engine RPM on the new control panel. If the RPM is outside 1550-1570 range, then set the high idle engine speed to 1560 RPM as follows. Loosen the throttle screw and nut of FIP. Adjust the throttle screw to set the high idle RPM in the 1560 plus minus 10 RPM. After setting the RPM, tighten the throttle screw and nut of FIP. Stop DG manually by pulling the FIP stop lever. Now, connect the new I-18 actuator to the new engine wiring harness. Check the DG's working. Check DG start, stop, running in manual mode. Check DG's start, stop running in auto mode. Check the variable speed operation. If you want to know the load on a variable speed genset, you need to measure both the DG output current and the DG output voltage. You need to multiply them to get the DG load in VA, watt. Do not calculate the DG load using DG current alone, like you do in case of a fixed speed genset, because that method can give you wrong results. For example, if DG output voltage is 150 volt and if the DG output current is 20 ampere, then the load on the DG is 150 into 20 is equal to 3000 VA is equal to 3 kVA. Let's look at another example. If the DG output voltage is 180 volt and if the DG output current is 10 ampere, then the load on the DG is 180 into 10 equals 1800 VA, that is 1.8 kVA. Thus, we have completed the retrofitment process. Your genset will now operate as a variable speed genset and will consume much less fuel than before. The Mahindra & Mahindra Sidomac variable speed technology benefits to you all the way.